Hello everyone, welcome to Math 7. So we have another problem on differentiation. This is from the application of derivatives and this is the question. The slope of the normal to the curve y equal to x square minus 1 by x square at the point minus 1 0 is. That's exactly what we need to find out. So we have to find out the slope of the normal to this particular curve, right? So the first thing that we need to do is to find out the slope of the tangent of this curve. So let me write down this curve once again. Y is given as x square minus 1 by x square. So this is the given curve. Now, what is the slope of the tangent to this curve? It is nothing but dy by dx. So let's find out what is dy by dx. So differentiating with respect to x, we get what is derivative of x square with respect to x? It is 2x minus what is derivative of 1 by x square? So 1 by x square is nothing but x to the power minus 2, right? And we know that the derivative of x to the power n is nx raised to n minus 1. So let me write it down. X raised to n, the derivative is nothing but n into x to the power n minus 1. So here my n is minus 2. So if I write d by dx of x raised to minus 2, then what I get is minus 2 into x to the power minus 2 minus 1, which is nothing but minus 3, right? So this becomes minus 2 divided by x to the power 3, right? So let me substitute that here. So what I get is 2x minus of minus 2 by x cube. That becomes plus 2 divided by x cube. So this is dy by dx, which is the slope of the tangent to this particular curve. Now what we need to find out is the slope of the normal. We know that the tangent and the normal, they are perpendicular to each other. So if this is the tangent, this will be the normal. So that means this angle is 90 degree, right? And we know that if you have two lines and if they intersect perpendicular to each other, the slopes of these two particular lines, their product will be equal to minus 1. That's the condition of perpendicularity of two lines, right? So if m1 is the slope of the tangent and m2 is the slope of the normal, we know that the product of the slopes, that is m1 into m2, has to be equal to minus 1, because this is the condition of perpendicularity of two lines which are perpendicular, right? So the tangent and the normal are perpendicular. We already got m1, which is dy by dx, that is the slope of the tangent, and we need to find out the slope of the normal. So let that be m2, and we know the product is minus 1. So what is m2? m2 will be minus of the reciprocal of m1, correct? So this will be equal to minus 1 divided by m1. Now let's find out what is m1 at the given point. This is m1, 2x plus 2 by x cube. Now what is the value of m1 at minus 1 0? Let's substitute x equal to minus 1 and y equal to 0. You only have x here, so let's substitute x equal to minus 1. So this will be 2 into minus 1 plus 2 divided by minus 1 the whole cube, which is nothing but minus 1. So 2 into minus 1 plus 2 divided by minus 1, both are minus 2. So minus 2 plus minus 2 will give us minus 4. So that means the slope of the tangent we get as minus 4. So the slope of the normal will be minus 1 by minus 4. That means it will be equal to minus and minus gets cancelled. It becomes plus 1. So you get 1 divided by 4, right? So what we need to understand is that if you are asked to find out the slope of the normal to the curve, first find out the slope of the tangent, which is nothing but dy by dx. And once you get dy by dx, if you take minus 1 divided by dy by dx, that will be the slope of the normal.